Hello and welcome to this video for Friday, April the 3rd for Calc Honors. It's going to be a continuation of the video from yesterday. Going to start off by looking at some of the homework that I assigned you in that video. You had on this worksheet that we see in front of us right now, we had questions A, C, and D to do. I'm not going to correct them all here, but I'm going to work through the first one. Now, in these videos, in these questions, you were given the graph of the first derivative f prime of a function f and asked to provide information about the function f. So you're looking at the graph of the first derivative and you're asked about the original function f. So let's take part A together. And what we were asked for is where the original function was concave up, then concave down, and then for points of inflection. Okay, so let's try that and see how we get on. So first of all, we'll look to see where the original function was concave up. So we're looking at the graph of the derivative. And the rule for this is that if the derivative is increasing, and we're talking here about the first derivative, I should stress that because the rest of this video we're going to be looking at second derivatives. So if the first derivative is increasing, then the original function is concave up. Okay, now this function, this first derivative, starts increasing here. It's increasing from here to here. Okay, so that's x equals 0 and that's x equals 3. Okay, so f is concave up on the interval. I'm writing it this longhand because I do want you to get used to the vocabulary. F is concave up in the interval from 0 to 3. Okay. Let's now talk about concave down. Okay. Question 2 is about concave down. And the original function is concave down when the first derivative is decreasing. Okay, so again, this is just a homework check on what I assigned you previously. F, the original function, is concave down on the interval. Well, there's going to actually be more than one of them because this decreases from here down to here. So that's from -6 to 0. And then it starts decreasing here again. Okay, it starts decreasing there again. So that's from 3 to 5. On the intervals from -6 to 0 and from 3 to 5. Okay, now it might make it easier for you to erase some of the shading there. Might actually be more helpful. Okay, and then 3 is to find the points of inflection. Well, you have points of inflection wherever the concavity changes. So the original function has points of inflection, and basically it's when the first derivative changes from increasing to decreasing, or when it reaches a max or a min. Okay, we'll call it a relative max or a min because we don't look at the endpoints. Okay, so this graph, this is the first derivative, and it starts at -6, and it's coming down, and it's still going down. It goes down more steeply, but it's still going down. It goes down, and it reaches its bottom there when x equals 0. So that's the bottom of this graph, and the bottom of that valley, beg your pardon. So it's a relative minimum on this graph, and the relative minimum for the first derivative, which means it's a point of inflection for f, for the original function. F has a point of inflection at x equals 0. And the way you justify it is you say because f prime changes, f prime is the graph we're looking at, changes from decreasing to increasing. And f has another point of inflection at, okay, so the other point of inflection is, if you look at this, at from 0 across here it starts increasing, and then it's still increasing, but at 3 it kind of reaches the top and then it starts coming down again. So at x equals 3, another point of inflection at x equals 3, because f prime changes from increasing to decreasing. Okay, so that's how you justify your answer here. Okay, so I'm not going to do the other two questions. Don't want to spend all this time, this video, just doing homework. But those are your answers for the first one, and that should give you a clue as to how to answer the others. Again, if you have any difficulty, if you run into difficulty with these, I'll post a key probably today or tomorrow, which is either Thursday or Friday, depending on when you're looking at this. And you can also ask questions online, or when we meet one another again as a class. Okay, so that was one question from the homework. And that was, in those questions in last night's homework, we were looking at the graph of the first derivative and trying to come up with answers about the original function. If you click back here, day 1, April 1, so we're going back a little bit, back to these notes, day 1, April 1. We hadn't completely finished the work we were doing. This is, if you remember, this is the page that we're looking at. Some of the photos haven't loaded yet. So it's day 1, April 1. And we're going to look at example 2. Now in example 2, what we're doing is we study the graph of f double prime. So we're given the graph of the second derivative. Okay, so let's copy this table here. Let's copy that table and pull it down, because we're going to use this table. And just put it down here. Okay, so now what we're going to do is we're going to be looking today at the second derivative, and we'll be asked questions about the first derivative. Okay, this is the one we see over here. See this one, but we answer questions about this one. So we're going to be questioned about this. Okay, so we're going to see the second derivative, but we're going to be questioned about this. The homework you did last night was where we saw the first derivative and we were asked about the original. Okay, so let's look here at the questions involved. So study the graph of f double prime, the second derivative, and answer the questions involved. So part A, write down the intervals in which the function f, which is not shown here, that's the original function f, is concave up. So if we have the second derivative is the one we're showing, f double prime. If we want to know where f is concave up, then over here we look to see where is f double prime positive, and that means above the x-axis. Okay, so number 1, f is concave up when f double prime is positive, and that means above the x-axis. Okay, well, f double prime goes above the x-axis at -3, and it comes down below the x-axis at 4. Okay, doesn't come down below the x-axis again until 4. So, let's try it like that. From -3 to 4. That's a quicker way of writing it because we're pressed for time again. Number 2. Write down the intervals in which the function f not shown here is concave down. Okay, so if we want f to be concave down, then we want the second derivative to be negative, which is below the x-axis. Okay, so f is concave down when f double prime is negative. In other words, below the x-axis. And that would be on the intervals. Okay, so it starts off here at -5, and it doesn't go above the x-axis until 3. So on the intervals from -5 to -3, and again at the end it goes below the x-axis here at 4, and it stays below the x-axis to 5, and 4, 5. Those are the places where f double prime is below the x-axis, and that tells us that the original function f is concave down. And then the last question for today, where does f, if we look at C, write down the x-coordinates at which f, not shown here, is a point of inflection, and in each case justify your answer. So f has a point of inflection when the second derivative is equal to 0 or is undefined and changes sign. Don't worry too much about the undefined one, we're not going to see that very often. So we're going to have f having a point of inflection when the second derivative is equal to 0 and changes sign. So where is f double prime equal to 0? In other words, where does it cross the x-axis? So f has a point of inflection when f double prime crosses the x-axis. Okay, i.e. at x equals, okay, crosses the x-axis first right here at -3, and at x equals 4. So those are the 2 points of inflection for f. Okay, it's where f double prime crosses the x-axis, the points of inflection for f. This is not, this one here at x equals 1 is not a point of inflection because the graph doesn't cross the x-axis. Okay, so we're nearly out of time. I want you to watch this video as often as you need, and then let's go to the homework that's given on April the 2nd. So the same worksheet you've been working on, I want you to do the 3 questions you haven't yet done. That would be question B and question E and F. They all show you the graph of the second derivative and ask you about the original function. So they're all based on the example we've just done. Thank you very much for watching. We're nearly up to the 15-minute limit, so good luck with that homework. And don't forget to get in touch with me by email anytime you want, and we'll set up a Teams call at a time when we're both free. Okay, God bless. Have a great weekend, and thanks for working and sticking this out. Okay, soon be Easter. God bless. Take care. Bye-bye.